question 1, we are looking at techniques of derivative. We have question A in here, where y is equals to square root of 2x minus 1 sinus 3 minus x. Step 1, we can turn them into y is equals to square root of 2x minus 1 times with sinus 3 minus x. And then after that, we can simplify the square root of 2x minus 1 into y is equals to 2x minus 1 to the power of 1 over 2 times with sinus 3 minus x. For step 2, we need to assign them into u and v, whereby u is equals to 2x minus 1 to the power of 1 over 2, and v is equals to sinus 3 minus x, sorry. And then after that, we need to derive them into du over dx and dv over dx. For step 3, we need to sub them into product rule, whereby dy over dx is equals to 2x minus 1 to the power of 1 over 2, and then sine negative cosine 3 minus x plus sinus 3 minus x times with 1 over square root of 2x minus 1. And for step 4, our final answer, whereby our final answer is equals to negative cosine 3 minus x times with 2x minus 1 to the power of 1 over 2 plus, and since we have sinus 3 over x times with 1 over square root of 2x minus 1 in here, we can bring it to the upper side, whereby sinus, we can get the sinus 3 minus x over square root of 2x minus 1. Moving to the question B, where y is equals to natural logarithm 5x plus 1 over cosine 2x. For step 1, we need to assign them into u and v, whereby u is equals to natural logarithm 5x plus 1, v is equals to cosine 2x. After that, we need to derive them into du, whereby du u into du over dx, and v, we derive them into dv over dx. After that, we need to sub them into quotient rule, whereby dy over dx is equals to cosine 2x times with 1 over 5x plus 1 minus negative 2 sine 2x times with natural logarithm 5x plus 1 over cosine 2x squared. After that, we can see that in step 2, cosine 2x times with 1 over 5x plus 1, so we can bring the cosine 2x to the upper side of 5x plus 1, where we can get in step 3 cosine 2x over 5x plus 1, and we also can see that in the negative 2 sine 2x, on the front of it is negative, so negative, we turn them into positive, we get plus 2 sine 2x natural logarithm 5x plus 1 over cosine 2x squared. And in step 3, we can see that each of them is in a lot of layer, and we can simplify them, whereby we can bring the cosine 2x squared to the front, where in step 4, our final answer, which is 1 over cosine 2x squared times with cosine 2x over 5x plus 1 plus 2 sinus 2x natural logarithm 5x plus 1. And that is our final answer.
For our question 2, find dy dx for 2y natural logarithm of 4x plus 3x to the power of 7 equals to 2 tangent x minus y minus exponential to the power of x to the power of 2 by using implicit differentiation. First of all, I will modify the equation into this, so it's going to be easy for me to differentiate it later. Then I will break the equation into 4 parts. That is part A, part B, part C, and part D. For part A is we're going to use product rule. For our U is Y, and for our V is natural logarithm of 4x. After we found the answer for product rule, then we can differentiate for Y logarithm of 4x, then we're going to get answer for dy over dx natural logarithm of 4x plus yx. For part B, we're going to differentiate x to the power of 7. 7, we're going to bring up to the front and multiply with 3x. And for the power, we're going to minus 1. And the answer we get is 21x to the power of 6. For part C, we're going to differentiate tangent x minus y by using chain rule. And the answer is going to be secant square x minus y times d over dx x minus y. And the last answer is secant square x minus y times 1 minus dy over dx. For part D, we're going to use chain rule. For our part D, we're going to differentiate exponential to the power of x to the power of 2. And after we differentiate it, we're going to get the answer that is 2x exponential to the power of x to the power of 2. After we differentiate for all parts A, B, C, and D, then we will sub in those values into the original equation. After that, we will multiply in the constant into the bracket, then we will find this equation. After that, we will isolate the variables that have dy over dx to the left side. Then, we will factorize the equation and we will divide both sides with 2 so that we can simplify the equation. Lastly, we will find the answer for dy over dx.
Question 3. Use linear approximation to estimate the value of square root 63.98 minus 4 over cube root 63.98 correct to 3 decimal places. For this question, we need to use 5 steps to solve it. For the first step, we need to determine the f of x, that is, f of x equals to square root of x minus with 4 over cube root of x, and also don't forget to write x equals to 63.98. For the second step, we need to use the equation x equals to x now plus delta x. For the value of x, we know that the value is 63.98, and also to find the value for x now, we need to find the nearest number with 63.98, that is 64. So to find delta x, we need to subtract the value of x with x now. That is 63.98 we minus with 64, so we get negative 0.02 for delta x. So the third step, we need to differentiate the f of x to become f prime of x. And the fourth step, we need to find the value of x now and f prime of x now by substitute 63 in the equation. Like this. And the last step, we need to substitute all the values that are related to the formula. And the answer for this question, approximately 6.999 in 3 decimal places. So when you do this kind of question, you need to remember to put your final answer in 3 decimal places.